This is a demonstration of the David Cattermole Maya Match Move Solver, which is available on GitHub. So what this does is that inside of Maya, it does pure brute force least square fit solves, and we can do a camera solve today and an object solve. It's similar to the brute force solver inside of Equalizer, which is called the LSF solver. So what we're going to do is that we will here's the GUI. And what we need to do, we need to do 2D tracks inside of Equalizer. And so right now the best one is probably the Export 2D Tracks UV. So the reason it's called UV is that it's resolution independent. The lower left hand side of the image in Equalizer is 0, and the upper right hand side is 1, 1. So you don't have to worry about the size of your image. Now if you've got an overscan plate with distortion, you'll have to do 2D tracks inside of Equalizer with your undistorted overscan plate rendered out. So right here we can create a new collection. So these collections, the first one will call let's say camera solve. You can call them whatever you want. And then the second one we'll call eyeball solve. And you can do these in any order. Let's go back to our camera solve. So we can see here, looking at the plate, the camera's moving slightly and then the eyeball's moving slightly, and we want to track both of those. For each one of them, we'll only track rotations to keep this example simple. So what we need to do is bring in 2D tracks for the eyeball. So right here, go to load markers, and here I've got the correct camera selected, and I already have some solves done, some 2D tracks done. And for the camera, I'll use this one here, and then I load it. And then we see here there's 3 different markers, and I'm going to rename these in a minute. Actually, let's rename this one now. Let's call this cam, and MKR means marker. You don't have to use any of these naming conventions, but it's a lot easier if you do. So again, just for convenience, and then we can see here that these 3 little markers here have come in. And if you look at them, they're actually just little markers in front of the camera here. And also, if you select here, you can change the depth of the group of these points. I'll put it back to 1. So now what I'm going to do is I'm going to bring in, so each one of these markers also has a bundle. So a bundle is basically a fancy word for a locator. So I'm going to call this, give this the same name. Again, you can name these however you want. And so they're automatically linked. It knows that this one's connected to this one, and this one's connected to this one, and this one here. So you've got a 2D marker and a 3D bundle. So the problem with these bundles is that they're all sitting at the origin. So what we want to do is we want it to be on the face here. So let's do a low-grade method of connecting these. We're going to do a point constraint. And then we're going to project. And there are other ways of doing this. We'll probably have a better way to do this in the future. So delete that constraint. So now we see everything's good, except for these bundles are too close to the camera. We want them to be on the face. So we'll take these 3 here, and we'll also select the human geometry. And here we'll go to the projector, and we'll just go in current frame. And so what you do is that you select the locators, the geometry you want to project into, and right click on the camera, project for a single frame. Let's see. now these are all the correct spot for a particular frame that we're on. So now we should be ready to solve. Oh, actually, so we have to take our 2D points, our markers, and add them here. And then this is where we want to take the camera and we're just going to take the 3 rotations here and we're going to add those to the list of attributes that get solved. We can solve for a current frame or for all frames. Okay, so now we can see that the camera is animating. So we've got a LSF solve, a brute force surveyed solve for these parameters, and you can, if you had more 2D point markers here, then you could add more parameters here. Also, you can add in different objects nodes. You could have like the scale of a cube for, like scale SX, and you could have any combination of attributes from different objects. It doesn't have to all be with the same object there. So we've got the camera solved. So now what we're going to do is, now we want to do the eyeball track. So let's go to eyeball. That's empty there. So now we have to bring in the tracks. So load marker. Again, we want to have it with that same one there, that same camera here. So now we've got eye track. So again, this is in the UV format, which is 0 to 1 instead of being pixels. It's lower left hand side is 0 0, upper right hand side is 1 1. Now if you bring in a TXT file from Equalizer, then it'll ask for the resolution, but with the UV it's much simpler. So we go here, load. So now we've got this new marker here. Let's rename this eyeball marker, and then we've got a bundle here. Let's call that eye. So again, this is a 2D point, that's a 3D point. So 2D point we'll add to the solve. Again, we've got 2 collections here. So we've got an eyeball and we've got a bundle. So these are going to be grouped together. What we have to do is we need to put these into a group. So the bundles for camera solves can be in the root. They don't have to be in a group. But if you're doing an object track, you have to group your elements together. So let's create a group. Let's call it iMaster. And then what we'll do is we'll constrain this null to the eyeball. So now we'll take the eye, drag that in there, and we'll take this eye bundle, because when this starts animating, it has to have the bundle as a child so that the whole scheme will work. Okay, so now this is actually still at the origin. So what we're going to do is once again, we'll get it into our viewport by constrain point. So there it is. Now we delete the constraint. Now what we can do is we can project it. Let this and the eyeball, project it. Let's see. Okay, so now it's been projected down. Take this. Be sure to unlock this. Give keys to everything. So now we've got the 2D point. We'll take the eyeball master, And in order to avoid gimbal lock, because it's pointed down, we're just going to animate and solve for RX and RZ. If you do another order, the eyeball would roll on Z, which would be very monstrous and painful. So anyway, for this particular one, since we only have one marker, we can only have two attributes. Now let's try solving, see whether this works. Okay. And there we have it. We've got a camera solve with LSF, with mmSolver brute force, and we've got an object track. So there's many other features that are possible to have in this interface in the future. There's many refinements, multi-camera options, but for the moment, that's what we have available.